Okay, Dr. Rebecca White, I'm looking forward to this conversation. It's not every day that I get the chance to talk to a PhD who knows the depths of something that I'm interested in. And algae is a topic that I believe is on the cutting edge of human development. There seems to be deep market opportunities and also extraordinary potentials in benefiting the biosphere by relieving stresses on our systems from multiple domains, including energy and agriculture, all the while sequestering carbon dioxide and elevating oxygen levels. Furthermore, it can enter into our food supply systems and benefit our health. Algae seems to be bound to play an integral role in future human systems. Algae likely was one of the first life forms to have appeared on Earth. And because of its position in the evolutionary chain, it seems to have synergistic capacities with numerous other life forms, from humans to bacteria. So I know a little bit about your background because I watched some of your videos. And I know that you grew up in an agricultural family, and then you went the academic route, and you found yourself studying algae, and now you're back in the agricultural realm, but from sort of different perspective, the scientific perspective. So what was it about algae that captured your interest?
Yeah, thanks for that introduction, Max. I'm really happy to be here, and that's a great opening question. As you said, I grew up in an agricultural family. My family has been farming in Texas for a number of generations, cotton, cattle, and peanuts mostly, although a few other things mixed in there over the years. And I went away to school actually to study viruses, is what I got my PhD in, molecular determination of virulence in different interesting viruses. And when I made the jump over to industry, I wanted to get into something that I felt was going to have really long-term impact on humanity and our planet. Not just emerging diseases, but really getting at some of the underlying fundamental problems that we're going to be facing, certainly in my lifetime and in my children's lifetimes. So climate change, for example, feeding the world is another one, poverty, those types of real big issues. Algae was interesting to me because, as you alluded to, it's the foundation of plant life. So it's given rise to all the things that we grow in agriculture, as well as all the other plants. And it's retained its photosynthetic powerhouse status. So if you look at total biomass on the earth, algae makes up a very small percent of that, something less than 5%, but it's doing more than 50% of the photosynthesis on the planet.
Wow.
So that's pretty significant, right? And you think something so tiny could do something so powerful and really help life on the rest of the planet to succeed and survive. The other thing that interested me is something else that you talked about, which is that there's huge potential, both in terms of the scientific malleability of the organisms that are called algae, as well as the product markets that they can touch. So they do everything from ecosystem services and remediation. So they can clean up water. They're used in wastewater treatment. They get carbon dioxide from the atmosphere. They're going to play a huge part in carbon capture and utilization, all the way to right now, they're used quite a lot in cosmetics, right? So anti-aging creams, some of the most expensive and best in class are based on extracts from algae. And there's everything in between: biofuels from the early 2000s, food and feed from the 2010s. Biomaterials are surging ahead right now. There's a number of different companies doing that. Basically, if you can imagine it, you can get it from an algae, or you can get an algae to make it. And combine that with their super photosynthetic productivity, and it just seems like we ought to be doing a lot more with algae than is currently mainstream.
Yeah, so there's like 70,000 different species of algae, and these single cellular algae species are kind of interesting. It's kind of like, we can print these like single cells and manipulate them in various ways and get these sort of like molecular components from them, like methane, for example.
Mhm.
Is it the case that like all of these different species of algae have like slightly different characteristics that can be like gamed to like reap the benefits from them?
Yeah, that's absolutely right. So my background, as you know, is in microalgae, but we shouldn't ignore seaweed and kelp and other macroalgae, which are equally as important and tunable by breeding, and produce a lot of important compounds as well. You look at the commercially available microalgae that are out there, and they're doing all different kinds of things, right? So most people will know microalgae in their daily diet from omega-3s. So if you're eating vegan omega-3s or you have DHA in your milk, that comes from an alga called Schizochitrium. Um, there's another alga that is close to my heart, which is Nanochloropsis, which makes EPA, another critically important omega-3 for human and animal diets. Then you look at something like spirulina, which is a cyanobacteria, a different type of microalgae. And it is great for protein and B vitamins and trace minerals. And so, that's just two or three off the top of my head. And then you get into the algae that make biomaterials, and you're talking about polyols. Those are different hydrocarbons that are made by the algae, typically membrane lipids. And then biofuels, the same sort of thing. High protein content, you're talking about chlorella and some other organisms there.
Is there like a wide variability between the different species? Like, and also because there's so many, like, have we even really begun to like uncover like the range of possibilities, that we can extract from algae?
Um, so there are substantial differences between the different species that are currently commercialized. So for example, Nanochloropsis is the only one that makes EPA in any quantity that's worth extracting, right? And Schizochitrium with DHA is the same sort of thing. There are a number of them that make protein, but when you talk about protein, you really have to get down to amino acid profile, and there are some pretty significant differences with amino acid profile. So some of them have a lot of branch chain amino acids, which are important for the human diet. Some of them not so much. So yeah, there's huge variability. And then you touch on pigments and other minor molecules in there, and you do get a high amount of variation.
You're one of the people that are starting to use algae before everybody else does, but I really do think that it's going to be huge at some point.
It is, and I think it's important to talk about what's holding algae back. So one of the things, when you look at all of the potential for algae and the different applications that are already in the market, my favorite is one of the algae biomass organization members, Algae, produces a product called Bloom Foam, and Jason Momoa has a collaboration with Rome, and he is making shoes that are out on the market that have Bloom Foam insoles in them. And that's super pop culture, right there. Aquaman doing aqua-based shoes. The problem is that a lot of the algae production is small scale compared to other bio-based ingredients. So things that come from soy, things that come from corn. We're talking millions of acres of production. There are millions of tons of
Right.
of product, and algae is still in the thousands of tons in the U.S.
I could see like entire states, being like algae doing algae production. Like, yeah, it seems like it's just so underutilized at this point. Like it really needs some development. And then there's all these processing, like different types of processing that needs to happen. That like infrastructure like needs to be built.
Sure. So that's exactly where I was going with that. There's a push to the market, and then you need market pull, right? And so the algae industry has been doing a push to the market for a really long time, and we can talk about a bunch of products that are out there that are being successful, but what we really need is pull from the market. So we need consumers to be aware that algae-based products are out there, that they're good for the environment. They're not just environmentally sustainable, but they're socially sustainable. Is something that consumers can feel good about buying. They need to be financially sustainable, and that's about establishing and de-risking supply chain and doing that at a scale and in a timely fashion to attract large companies to have algae as part of their products. And that's really where algae is today, is we're on the cusp of that breakthrough.
Definitely.
And yeah, and so really getting mainstream, I think, is where we're going to be focused next as an industry.
Well, as a country, we seem, and also as like a species, we seem to sort of be on the verge of moving into that like green developmental infrastructure phase. Elon Musk just put out some offer, for technology that would sequester carbon, and he would award them with a certain amount of money. And algae definitely seems like an obvious thing to try to make that happen.
Yeah, for sure. I think if you look at different groups that have initiatives like that, the play where algae can be the most successful, I think, is in those ecosystem remediation services, like we talked about, removing carbon from the atmosphere, removing nitrogen and phosphorus from water, from ag runoff, or at wastewater treatment plants.
Oh yeah, so I wanted to know about like the inputs into algae. Like, what kinds of nutrients do you need to feed them? Is it like largely just water and then the nitrogen from the air and then the CO2 from the air, or are there? I mean, I intuit there's more inputs like nitrogen, or what do you have to feed
Sure.
the algae?
So there's a couple of different ways to grow algae. You can grow them in large open ponds, which is what my background is, and that truly is like agriculture. So the inputs are very similar. We use agricultural fertilizers, so nitrogen and phosphorus. There's iron fertilizer that's required as well. Depending on the composition of the water that you're using, a lot of groundwater or even seawater has trace minerals in it. You may need to supplement that for some minor minimal minerals like molybdenum, but that's going to be based on where you are and what your water source is. The other way to grow it is in closed systems. So if you're not in the sunny Southwest where I am and you get hard winters, you're probably growing it in a closed system, either with light or with a carbon source. The photobioreactors that are closed systems that use light and carbon dioxide as the primary feedstocks for the algae. It's very similar to growing it in open ponds, very similar inputs. When you get into algae that can be grown on carbon sources, that's where it starts to get interesting, because carbon sources can vary. You can grow them on acetate, you can grow them on regular sugar. You can grow them on all kinds of things. But the primary inputs are the same as for any plant that you're trying to grow at scale. You need NP and iron. For commercial agriculture, it's typically nitrogen, phosphorus, and potassium. So that is a little bit different. And then you've got to have your magnesium, your molybdenum, your zinc, those sorts of things, all the bits that make up the plant cells.
Interesting. So I've been learning a lot about soil because I'm interested in starting a small farm.
Mm-hmm.
And in my journey, learning about what soil is and how it works, and I started thinking about compost and thinking about the farm as sort of like it's like in a way it's sort of like a bioreactor. You need all this mass there,
Mm-hmm.
and then you generate all of these microorganisms. Could algae play a role in like building compost, for example?
So that's a great question. Definitely the microbiology of the soil is a very important component for a number of reasons. And actually, one of the most successful current applications of algae out there is as a soil amendment or fertilizer. There's several different things that the algae do. One is they help, I am not a soil scientist, so I'm not going to say this correctly, but they help the matrix of the soil. And so you retain more water, you retain more of the nitrogen that you put on, you retain more of the phosphorus that you put on in terms of your fertilizer. And so you don't lose it to runoff. You can do less. Depending on the type of soil amendment or biofertilizer that you're putting on, it can, as you said, be part of the microbiome that creates just a more beneficial environment that can lead to yield improvements and things like that. So for sure, algae is being successfully used in those ways already today.
So I've heard that the cell wall of the single-celled algae of this, like the cell membrane, is difficult. It sort of breaks down a lot slower than some other things. Is that true? And would algae need to go through some sort of processes before, like, I'm thinking about, just biomass, like, and like essentially what it is it's just stored sunlight and solar energy. Algae is one of these things on Earth that it's like little batteries, it stores the energy really, really well and efficiently. And I wonder, I wonder what kind of role that could play in building and restoring soil, like and like, could like a compost like factory, for example, like, could they put a lot of processed algae into their compost piles, and would that be different than if they didn't process it in a certain way? Like, what about algae? Like, how can a small farmer use algae, and is it possible to sort of just run kind of natural processes and get some sort of benefits from it?
The first thing you asked was, do algae have more difficult cell walls to break than other things? It depends on the context and it depends on the species. So some algae have very difficult cell walls to break. They're highly cross-linked, they're very thick. Other algae are kind of fragile. So spirulina, for example, you have to harvest by filtration because things like centrifugation will actually break the trichomes. So it depends is the answer.
Okay.
The other thing is, can small farmers use algae to improve their soil? Absolutely. The answer is yes to that. The example I'll point to is a company called Algaeternal, which makes a product from algae called Elixir. And they have tons of small farmers that are using that and seeing improvements in their soil quality as well as yield improvements in their plants. Could a small farmer grow their own algae and use that directly? I think if the farmer wanted to get that invested in it, the answer is absolutely yes, that you could do that. There's different ways to quote unquote micro farm algae for your own use. The thing that I think is hard about that is the harvesting, because they are single-celled organisms. And if you are not wanting to invest a ton of capital in a harvesting system, I think that's where you'll have trouble, is just harvesting them for your own use. But there are plenty of great products out there already for small farmers, and they're available nationwide.
There seem to be also like all like potentials, like if a small farm had like a big pond, it could grow a bunch of duckweed and then use that duckweed to feed like chickens or maybe some tilapia, or can you get proteins and what kinds of nutrients can you get from something like duckweed?
Duckweed is a great source of protein. It's got some other micronutrients in it. It's got chlorophyll in it. It is easy to harvest. I think easy to grow is relative depending on where you are geographically. Because like most plants, it's got a temperature range, right, and sunlight needs that you need to meet. But I think that's a great example of what you could do as an individual farmer on your own farm to supplement, what you're already feeding to your animals. I think one of the interesting things about the algae community is you have a large group of folks who are trying to make commercial efforts work. So, I mentioned Algaternal, there's Helier, there's Grosswind Technologies, tons of companies, right? And they're putting products on the market for farmers and others to use in their process. And then there is this micro farming algae movement that's also going on. And that's primarily spirulina for food, because spirulina's big cells. You can, as I said earlier, harvest it by filtration. You can actually do it with bed sheets. There's tons of fun things that you can do with spirulina to supplement your own diet. Spirulina is good as an animal feed as well as for human nutrition. It's great for aquaculture feed as well. So I think on the one hand, I really admire the folks that are wanting to do their own thing and supplement what they're doing on their farms by adding some algae or duckweed, or these other alternative crops, if you will, on a really small scale. I think what the industry really needs is support for the commercial efforts that are going
Absolutely.
on.
Yeah.
Right. And the domestication of those strains will then lead to improvements that will make it easier for the folks that are wanting to do it on their own farm. They'll be able to do it on their own farm because all the kinks will have been worked out. Right.
Yeah. Yeah, I think we're moving in that direction. I mean, it's like the electric car, it's like it just works out because it's so efficient at what it does. And eventually,
Right.
We're going to figure out that there's a lot of potential there, both market opportunity and, it's going to benefit our planet as well and our health,
Yep.
and stabilize all the various systems that we have. So
Yeah.
with that, yeah, I just want to say thanks for taking time out of your day to speak with me, and also thanks for the work that you're doing, because I do think that you're on the cutting edge of something that's important, and it's benefiting humanity, and you're kind of breaking the ice for other people to enter into the space. So thank you, Dr. Rebbeca White.
Well, thank you very much, Max. And I'd like to invite you and any of your listeners to join us at the ABO Summit later this fall. You can go to our website, algaebiomass.org, to find out more. And Max, I hope to see you there.
Cheers. Thank you.